ask you to do is it's going to be identify all these different graphs. Okay, so let's like run through those really quickly. And kind of like how you can memorize them. Okay, what's this first one? And why do we know that? Line, linear. Okay, cool. What about this one? Absolute value. And why do we know that? It's a V shape. Value starts with V. Cool. All right. What about this one down here? Quadratic. How do we know? The U shape and quadratic has that U, right? Okay. What about this one? Exponential. Why do we know that? That one's hard to like come up with some. So it's what? Okay. All right. I like that one. Expanding. Okay. Or it's growing exponentially fast. Okay. This is one of those you just kind of have to know. What about this guy? Square root. How do we know? This one always makes me think of this symbol, which is square root. It kind of like looks like that, kind of. Okay. What about this one? Cube root. How do we know that one? You may not know what a cube root looks like, but it's like this. Again, that like swoop looking thing. Cool. You got to know what each one's name is. Okay. You are given like a word bank, but you still need to know which each picture is. Okay. Which one of these does not have a domain of all real numbers? So what I mean by that is from negative infinity to positive infinity. So real quick, all real numbers is the same thing as negative infinity to positive infinity. Which one does not have that? You said square root. Any other ones? The exponential keeps going this way, right? And that way. Trick question. Square root is the only one. Yeah. Okay. Cool. Questions? What about in behavior? How do we figure out in behavior? So if I said x is approaching positive infinity, y is approaching positive infinity, x is approaching negative infinity, y is approaching negative infinity, which one of these does that? Which one? Cube root? It does. Cube root would work for this one. Anything else? Linear? Okay. This linear one? So as we move to the right, what's happening to our y values? They're going up. So that describes this. And then as we move to the left, this is going down. So that describes the second one. Cool. Okay on that notation. I know in behavior is a little tricky. Speak now, forever hold your peace. Okay. All right. Increasing and decreasing, kind of, how do we figure that one out? How do we figure that out? What do I always tell you to think of? You're at Six Flags and we're on a roller coaster. And we're starting over here. Are we increasing or decreasing on this linear? Okay, and how long are we increasing for? The entire time. So from negative infinity to positive infinity. Cool. All right, now for absolute value, it decreases and then it increases. Everybody see that? Okay. Cool. I'm not seeing a whole lot of blank stares. Good, good. Okay. One thing I do want to talk about is, remember how yesterday we were talking about word problems? And actually, I think I'm going to pull that up. One moment. We were talking about word problems and we were talking about like in context domain stuff. And it was a little trippy because it wasn't like all the other stuff that we've done. There we go. Domain. Okay, so like this one. You remember this one? Okay. So we had a 350-gallon tank and water's draining, right? There's the equation. And we're trying to figure out what the domain is. Okay. On one of the problems, you're not going to be given the graph. You're going to be given like what's going on in the scenario. Kind of like this one without the graph. Okay. Yeah, let's talk about this one. So we got tennis camp and it charges $40 per student. The camp runs only if at least 5 students do it and limits it to 16 campers a day. Okay, here's your equation. Okay, now what are possible inputs? What are possible domain values? 5 to 16. Now, my question to you, 5.5 is in between 5 and 16, right? Now, can I plug in 5.5 numbers of students? No. So it would have to be whole numbers, right? Okay, back in the day, you learned about words such as integers, real numbers, and irrational numbers, and natural numbers. These are all words that you've learned in the past. Now, I know we've forgotten them, so let me break it down for you. Integers are like whole numbers that you can count. They can be positive, they can be negative. Cool? Real numbers is anything between 1 to the next number. That could be 1.1, that could be 1.5, etc. Okay? Irrational numbers are things like pi and the square root of 8. Anything that deals with not whole numbers and numbers that are not repeating. Okay? These are like real wonky. We don't deal with these in real life scenarios. Okay? Natural numbers are the numbers that you learned in like first grade, like 1 through 10. Does that make sense? Again, you know these words, you just have to make sense of what's going on here. So, going back to our scenario, we've got these kids that have to be from 5 to 16. Which one of these words talks about this domain? So we got from 5 to 16. Are we going to use integers, real numbers, irrational numbers, or natural numbers to describe this? Integers. Why integers? Can we have half a kid? We can't have half a kid. They have to be whole numbers. Does that make sense? Okay, you've seen this word before, but it comes back up. Okay. What about if I say the term multiples of 5? What does that mean? Multiples of 5. Think back to elementary school. 5, 10, what else? 20. So it's kind of like you take 5 and you can multiply it by any other number. That's a multiple. Okay, again, those are words that you learned back in elementary school. Okay. Everybody good on that? Okay, I'm gonna go back to the review. Okay, so talking about that bird scooter thing, we got this equation, and I want you to interpret what E of 3 equals 1.45 means. Okay, so here's the easy way to do it. When you're given something in context, look at where it says X in the problem, like up at the top, and see what it defines X as being. So what is X in this scenario? Okay, so how many minutes do we plug in? Okay, so after 3 minutes, and we're representing the total cost, right? How much is it going to cost? So it's going to cost $1.45, right? That's all it means by interpret. Now, if I say find E of 10, what would I do here? Plug in 10 into the situation. I got 0.15 times 10 plus 1, right? And that gave us 2.5. Now, so what does this mean in context? This means after how many minutes? How much is it going to cost? Cool. Now, if I said, find how long, okay, let me write this out. Find how long you rent if you spend $5. How would we go about solving that one? Say again? Are we plugging in 5 minutes? Because what is the question asking you for?
And then you do 0.15x plus $1 is equal to 5. And you solve it.
Why are we setting this equal to 5 instead of plugging 5 in?
Is that the cost?
That's the cost. So be careful about how they word it. So this asks for how long. So this is asking to find minutes, right? And you told me that x is minutes. So I would take this and set it equal to 5. And then I would reverse PEMDAS. So I would subtract 1. And then divide by 0.15. And I don't know what that is off the top of my head. Okay, so we would do 4 divided by 0.15. And that's going to give us x equals 26.7-ish. Cool. Questions? Okay. The last question that's on your test is going to ask you about creating an equation from the table. So you remember how we did on page down here, this junk with me? Okay, if I were to ask you to write the equation, what equation am I going to really look for? Well, it's a linear function, right? Because that's what we've been talking about. So we got y equals mx plus b. How did we find m and how did we find b? How did we find m? Tell me what m stands for. Let's go there. Rate of change, so slope, right? And what does b represent? Good, y-intercept. Okay, so the y-intercept is when x is 0. With me? But we've got to find the rate of change. So what we're going to do is we're going to subtract and subtract. What's the difference between 5 to 8? And what's the difference between 170 to 260? Okay, so 90 divided by 3 is how much? Okay, so the slope is 30. Let me see how I do that. Okay, now the y-intercept we got to find by calculating it backwards, right? So we're going to take 30 and we're going to subtract it 5 times. And that gave us 20. So then we said 20 for our y-intercept. So here's our equation. Okay. Now, if I said, here's Bianca's equation, and I want to figure out how long it's going to take her to save up to equal $500, how would I go about solving that? I want it to find how long it would take for $500. What would I do? Well, what does X represent? Mm-mm. So this is going to be the number of weeks. So X represents the number of weeks. And what does Y represent? So the money, so the cost, right? So if I ask, how long is it going to take? I'm searching for X. And I'm going to take 500 and plug it in for Y. So 500 equals 30X plus 20. So what am I going to do first here in order to solve? Subtract 20. And that's going to give us 480 equals 30X. Now what am I going to do? Divide 480 divided by 30. And so X is going to equal 16 weeks. you have to be careful and pay attention to what are they asking you to find. Are they asking you to solve for X? Are they asking you to solve for Y? Okay. If they ask for how long something's going to take, you're solving for X. The number of minutes, weeks, years, whatever. Okay. Questions? Okay.